Hey everyone, welcome back to AP Precalc. Today we're going to be covering FRQ number 2. Let's get started. So here's the bell ringer. Do 3-peat K now. Pause the video if you haven't done it yet because I am about to go over the answer. All right, so for the first one here, we want to find which of the following statements is true about K of x, which is that polynomial there. And we're looking at the interval from negative 0.75 to 0.75. And here, this is important because they give it to us in interval notation, but when you type it in Desmos, if you type that in verbatim, it would give you, or just plot that coordinate. So you are always going to want to enter that in inequality notation in Desmos. Plotting that, it will highlight this area of the graph, and looking at this, it's hard to see on the screen, but it is below the x-axis. So k should be negative, so we can eliminate a and b. And then the function is going down, right? As you go from left to right, so it is decreasing, making D the correct answer there. All right, number 2, consider the logarithmic functions f and g defined by those two equations there. What's a 0 of f minus g? So I would type in all three equations verbatim here. Here you could even have h of x equals f of x minus g of x for that third equation. Now remember, how do you get that custom log of log base 6? You're going to go to your keyboard in the bottom left corner, and then you are going to click the functions on the top right of the keyboard, and you're going to scroll down to the calc section, so the calculus, and look for log base a. Hit that button, and that will allow you to enter a custom base for a logarithm. Here we're looking at the 0, or trying to find the 0 of h of x, so that blue line. So pay attention to what color you're looking for. Hover over that point, and you should get 1.037 as your answer. So C would be the correct answer for number 2. Number 3, the table right here presents values for function f at selected values of x. Here we're using a sinusoidal regression to model this data, and we want to find the prediction when x is 7 and find f of 7. So what I'm going to do first is add a table in that top left corner, enter our data points verbatim, and then in the drop down, once you see that, to get that drop down, remember, you're going to click that little icon right there and go to sinusoidal regression. So remember, all the questions will tell you what type of regression model to use, whether it's quadratic, exponential, logarithmic, or in this case, sinusoidal. It will automatically have the equation graphed. You could copy and paste it like I did there, and then find f of 7, replacing y with f of x to get your answer. So 4.62 should be our answer here, so B. What you could also do is, if you don't want to do this and go through all that hassle, just graph the line x equals 7 and find your corresponding y coordinate. So B should be the correct answer here. All right, so today we're going to be covering FRQ number 2. This is going to give you a story problem in context, and you're going to have to deal with one of the 4 functions, either quadratic, exponential, logarithmic. So those 3 we've seen before. And today we're going to introduce piecewise functions as well, which is a combination of any of those 3. With this question, you will have access to Desmos for the entirety of it, and you will need to use it to do some calculations and stat regression. So I'll go through an example problem and explain what you can see, and then we'll do some side examples in between as well. All right, so the context for the main problem we're going to cover is a student won $500 in an art contest. And now, at first, the student just keeps the money sitting around and does nothing with it. And then after 10 months, they get the bright idea to start putting that money in a savings account, which will ultimately earn interest. 6 months after they started that savings account, the account balance was $508.67. And then 12 months after depositing the money, the amount in the account was $517.50. So this is going to be our function for m of t, is this piecewise function here. Notice how at time t equals 0, this is when our account opens. So account opens at time t equals 0. which means that when we see 500 for when t is between -10 and 0, that's because there was 10 months that we had the $500 that it didn't grow, it didn't do anything, but that was 10 months before we actually opened the account. Then as soon as we open the account, you're now going to switch your function, right? It's a piecewise function, to the bottom function, which is going to be an exponential growth for this savings account. So where M of t is the amount of dollars in time t months since the $500 was deposited, a negative value for t represents the number of months before the student deposited the 500 into the savings account. All right, so question 1 here. This question will always be the same year after year. Use the given data to write two equations that can be used to find the values for constants a and b in the expression for m of t. So if you remember m of t here, our expression was a piecewise. It was 500 for when t was in between -10 and 0, and a times b to the power of t over 12 for when t was greater or equal to 0. So here what I would do is write your two coordinates that you were given from the equation. Our two coordinates should be 6, 508.67, and then 12, 517.5. Once we have our two coordinates, we're going to plug them in for essentially x and y. In this piecewise function, we want to know what function do we plug it into, whether it's the top or the bottom. And this function should be plugged into the bottom function here because here we see t is 6 and 12. Those are both greater than 0, so they're going to meet the criteria for the bottom function there. Plugging this in, you should get 508.67 equals a times b to the power of 6, which is our t, over 12. And that is equation 1, because this is essentially the same as y equals a times b to the power of x over 12, and you're plugging in your x, y coordinates. The next equation, very similarly, will be 517.50 equals a times b to the power of, a times b to the power of 12 over 12. And so here we don't even need to simplify the fractions. 6/12 and 12 over 12 can be left like that. Don't worry about simplifying those there. So that should be our answer for question number 1. All right, example number 1. Write equations that can be used to find the values of a, b, and sometimes c in each expression using the 2 or 3 points given. We don't need to solve for a, b, and c. So number 1, this is very similar to, I will write this always in terms of x and y. Y equals ax squared plus bx plus c. And then I'm going to plug in each coordinate in for x and y here. So our three equations should be 21 equals a times 1 squared plus b times 1 plus c. Here then we have 8 equals a times 5 squared plus b times 5 plus c. And then 17 equals a times 9 squared plus b times 9 plus c. That should be our answer right there, just those three equations by itself. And so that is our answer to part A. For part B, g of t is equal to a plus b ln t plus 1. Here we are going to do, this is similar to y equals a plus b ln x plus 1. So plugging this in, I should get 12 equals a plus b ln 0 plus 1. And then the next one should be 17 equals a plus b ln 2 plus 1. And that should be our answer for example 1a and b. All right, so for example 1c, we have a piecewise function here. The first thing we want to do is for each point, we want to see which function, whether it's the top or bottom function, that we're going to plug it into. So for the first point, when t is 2, that will be plugged into the top function because t is between 0 and 6. And so we're going to set our y value, 18, equal to 7a to the power of t, which in this case is 2, over 2. And we can leave it like that. That is our answer for our first equation. And then our second equation is going to be based off of this point. Here, 17 is bigger than 6, so that will be plugged into the bottom equation. That equation will then be 21 equals negative 213.29 plus b ln of 17 here, plugging 17 in for t in the equation. And this is going to be our answer for 1c. Notice how sometimes with piecewise functions, you may need to plug it into the same equation or plug it into different equations based on your values of t. All right, for d, here we have an exponential function. Notice the t plus 1 in the exponent there. Plugging in these points, we're going to get 22 equals, so 22 is like our y value. That will be equal to a times b to the power of 0 plus 1. And we can leave it like that in the exponent. And then the next one is 1 equals a times b to the power of 3 plus 1. And that should be our answer for 1D. All right, so question 2 will always require the use of Desmos, and it is going to do statistical regression. So what we want to do here is we want to find the values of a and b as decimal approximations. Notice how this means 3 decimal places. If you give me more, that will always be fine, but if you give me less, it will be marked as incorrect. All right, so what you want to do here is you want to first click this plus sign and then add a table in the Desmos screen. Once you have your table, you are going to plug in your 2 points into the table and then choose the correct regression equation. So first, what points do we plug in the scenario of this problem? And it's pretty easy, right? If we have both functions being 508.67, 508.67 equals a times b to the power of 6 over 12. And then we have 517.50 equals a times b to the power of 12 over 12. This is going to be mimicking an exponential regression, right? And so this is exponential regression, but remember, exponential regression is for Desmos in the form of a times b to the power of x. So what we have to do here is taking these two equations, we should get 508.67 as our y value here for our first point. And then our x value is going to be, because it's y equals a times b to the power of x, 6 over 12, so 1/2. Our next coordinate we're going to plug into our table is going to be our x is 12 over 12, which is 1, and then our y value is 517.50. So remember, you have to match your points to kind of mimic Desmos's regression equation because they don't have a lot of flexibility in that, but you can in how you enter your points in Desmos. So that's why we should have these 2 points here, 0.5, which is 1/2, comma 508.67, and then 1, comma 517.50. Once we have this, we should get our regression equation, which in this form, 499.991 is going to be our value of A, and then 103 or 1.035 should be our value of B. Right, so let's go through a few examples. Filling out this table, fill out the chart of the values of A, B, and sometimes C in a quadratic form, given a certain number of coordinates and then the form of the equation. So for quadratic, what I would do is create a table, enter these 3 points in verbatim, and then hit this drop down and look for quadratic regression. Make sure that you do not accidentally hit quartic or linear. A lot of students did that on the semester summative. Here, your A value is going to be the first coefficient here. So 1.85, and then rounding that should be 8. You could also put 1.857 and be okay. Here, our B value is, just so we can see it, a negative 21.888. So that's going to be our B value here. Don't forget the negative sign or else it will be marked as incorrect. And then here, our C value is 84. So that should be our answer there. All right. Now for an exponential regression, I'm going to plot the same, I'm going to add a new table, right, because this is a different question. This is a times b to the power of t, right? So here, I just have these points, and so I'm going to take a look, pick exponential regression, and then use this equation. This is a, and this is b. So a should be 1.668, and then b should be 1.549 rounding. And that's going to be our values for A and B for that exponential regression. For the third one, for logarithmic, now this is really important because for the first time we see a t plus 1 on the inside of the parentheses. And watch out, you may or definitely could see this on the semester summative. And so if you see t plus 1, Desmos's logarithmic regression line will go to the standard like default form of a plus b ln x, or what, right? So y equals that. That's the equation you see there. It does not encompass the t plus 1 or the x plus 1. So that's something that you're going to have to make as well by adding 1 to the x coordinates of both points. So you should plug in 1 comma 230 and then 8 comma 270 to get A as 230 and B as 19.236. So A is 230, B is 19.236, and that's our values of A and B there. For the final one, when you have a piecewise function and it's two separate equations, then I would say don't use Desmos's regression tool. Just use a calculator and use Desmos more as a calculator than building a table here. If it is in like the case of the example that we've been working on with the bank account savings, that's one where I would use Desmos because they both fall under exponential regression. Right, so taking a look at this one here, our two equations, if we plug in those two into the piecewise, would be 15 equals 7a to the power of 2 over 2. And then our second equation would be 67 equals negative 213.29 plus b ln of 6. And the reason why this gets plugged into the bottom equation instead of the top is because this is for when t is greater or equal to 6. And here it's equal to 6. The top equation is, if you look closely, where t is less than 6, and 6 is not strictly less than 6. Right? Now that we have our two equations, let's solve for a and b by hand. So here, anything to the power of 2 over 2, which is 1, is just itself. So this is 15 equals 7a. Then I'm going to divide both sides by 7. So a is 15 over 7. And then as a decimal, because we want decimal approximations, this should be 2.143 as our answer for A. All right. For B, here we have 67 equals negative 213.29 plus B ln 6. I'm going to add 213.29 to both sides to get 280.29 equals B times ln 6. ln 6 is just a number, so we can divide both sides by ln 6 to then get B is equal to 156.433. And that should be our value for B in that piecewise equation there. All right, question number 3, this will always be the same. Use the given data to find the average rate of change, which is another word for slope. Between 2 points, between t equals negative 2 and t equals 12. Here, there's two things to notice. We want a decimal approximation, and then show your work as well that leads to your answer. So it will always ask you to find the slope between 2 points. The tricky thing here is typically it'll be just 2 points that they give you in the question. That will typically be seen. With this example here, they actually don't. Our two coordinates are going to be negative 2 comma something and then 12 comma something, right? And so first off, We know what the y coordinate of 12 is from the question. It was 517.50. So that you don't even have to use the equation. You can just pull from the points that they were given to you. All right, -2 though from the piecewise function is, remember, when t is between -10 and 0, I think it was m of t was the function name, that was 500 because it was $500 just sitting there for the first 10 months before he even opened the bank account at time 0. So at time -2, he obviously only had $500. So that's our second coordinate. And then we need to plug this into the slope formula. Remember, average rate of change, or slope, is y2 minus y1 over x2 minus x1. I've had people flip the numerator and denominator, so just make sure you don't do that. Looking at that, we should get 517.5 y2 minus 500 y1 over 12 minus -2. This should give us 17.5 over 14. Here, a lot of students will or could just leave it like this. This would be wrong because even though that's the correct fraction, we want a decimal approximation. This then should give us 1.25 as our answer here. All right, so for example 3, we want to find the average rate of change between the following points. Express your answer as a decimal approximation and show your work. When I ask you to show your work for this question, I really want to see one of those two quotients. So for the first one, remember, we're going to do 4 minus 9, so y2 minus y1 over x2 minus x1, 7 over 0. This should be -5 over 7. So one of these two fractions I want to see in your work. This would not be a correct answer because we need to convert this to a decimal approximation there. Right, the next one here, we have 21.4 minus 1.3 all over -8 minus 2.5. Subtracting those, we should get 20.1 over -10.5. And then this should be -1.914 as our answer for part B. All right. All right, so for question number 4, this will ask you to interpret the meaning of your answer from question 3, the slope that you just found, in the context of the problem. And this is one version, one iteration of question 4. There's another one that we'll get to later. And so here's a general template that will always work for interpreting the average rate of change. However, I'm just going to show you what AP is really going to be looking for when they grade your answer. So the first thing that AP is going to be looking for is the time frame. So here I would start with from and then t equals blank to t equals blank and your two t values you used to find the slope. So from t equals -2 to t equals 12. And then here I would want, what are we looking at? What is changing? What is our unit of measurement? And here that's going to be the amount of money in dollars that the student had. So I'm going to say from t equals -2 to t equals 12, the number of dollars the student had in his account. So it's a little lengthy, but just bear with me. And then now I want to say what happened to it. Did it increase or decrease, and by how much? And so here, it increased or decreased is going to be based on whether your slope that you got in question 3 was positive or negative. Here we got positive 1.25, so we are going to say increased by 1.25. If it was -7, let's say, then we would say decreased by 7, not decreased by -7, but decreased by 7. So here, from t equals -2 to t equals 12, the number of dollars the student had in his account increased by 1.25, and then we're looking for our unit. And our unit will typically be found in question 3, if you look carefully. And the key word to look for the unit is the word per, because it's going to be something per something. And so looking for the key words around the word per in the literal wording of question 3 will help you form your answer to question 4. So here, looking at question 3, if you go back to the notes or your PowerPoint, it should say, use the given data to find the average rate of change of the amount of money the student has had in dollars per month. That's going to be our unit. So increased by $1.25 per month. And so it should be our y variable per our x variable. That's a little bit wrong. I'll fix that. And that is going to be a correct answer for example 4. The 3 parts I would be looking for on the semester summative is your time frame, what is changing, did it increase or decrease by, and then what is that unit? That unit is something I'm going to be looking for, this and the time frame, and then just this can vary, right? The number of dollars the student has had in his account. You could just say the amount of money the student had, the bank account the student had, something along those lines. That can kind of be open to interpretation, but the rest of this is pretty strict on what I'm looking for. All right, so here's the alternate version of question number 4. This is probably more likely to be seen on your AP exam, but there's a 50% chance you see this on your semester summative. So what this question is it wants you to use m of 12, which we know is the point 12, 517.5, and then they want you to use the average rate of change found in part 1. That's just the slope that you found. So we have a point and we have a slope. And we want to use both of those things to estimate the amount of money, in dollars, that the student has when t equals 20 months. So we want to know, what is our y coordinate when t equals 20? What's that y coordinate? And then we want to show our work that leads to our answer, which means that we can't really just use Desmos. We can use Desmos as a calculator, but we can't use Desmos to just find the answer without showing any work, because then it will be marked wrong. So I know some of you guys know how to do this, but you do need to show your work for this question on the semester summative. So what you want to do is you want to use point slope form. Remember point slope form, and so this is the working, is going to be y2 minus y1 equals m times x2 minus x1. That is point slope form. If you look online, you can look on how to use it, but it pretty much is a slope equation just rearranged, right? Once we have point slope form, you need 3 things. We need point x1 comma y1, we need an x2 comma y2, and then we need an m. We know our m, that's our slope that we found in question 3. That was positive 1.25. So we got a third of it out of the way. We also know our point. That was what we were asked to use, which was 12, 517.5. That is going to be our second point. And then our third point is going to be what we're solving for, right? We need something that's a little bit of a mystery in this one. So we're going to have 20 be our x coordinate, and then we want to solve for y2. We don't know what y2 is. We're going to plug this all in, all 3 of those things, into this equation. So here, this would be y2, which we don't know, minus y1, which is 517.5, equals 1.25 times 20 minus 12. And that's going to be how we set up our equation. And now it's just a matter of solving an algebraic equation. But remember the steps, because a lot of people made small, silly calculation errors in terms of just solving a simple equation like this. Remember, with the points that you plug in, sometimes it may not be given to you like it was here to use m of 12. So remember, when you get to pick and choose, it must be one of your 2 points you used for your slope. This is really important, and I saw this mistake on the semester summative in the context of a quadratic function when you had 3 points, right? You had 3 points to form a quadratic, and you used the one coordinate that was not used in the slope equation, which then would be wrong. And so that was the biggest mistake I saw in the semester summative. So if you see a quadratic scenario either on your semester summative or AP exam, do not make that same mistake again. All right, so now when we're solving this equation, I would start by simplifying the parentheses. So here, 20 minus 12, I know that's 8. So let me just replace this inside parentheses just to the number 8. Once we know that, 1.25 times 8 using a calculator is 10. And then I'm going to add 517.5 to both sides to get y2 equals 527.5, and that should be my answer. All right, and so this is the amount of money the student had when t equals 20 was approximately $527.5. Now, in this context, it's okay to have decimals. Another mistake I saw in the practice exam was a lot of students would round, which is okay. You can round to 528 or just 527 if you round down. That's totally fine, but somewhere in your work, I need to see the complete and full decimal. If I don't see this in your work, you will have the whole answer be incorrect. So don't lose silly points like that. Make sure that you show all your steps and include that final answer to 3 decimal places at least. All right. All right, so now we need to estimate the amount of money in dollars that the student had at time t equals 23, for example 4, and t equals 3 months, for example 5. This is assuming that you're working off of the same problem with the point 12, 517.5 as your x1, y1, and then with a slope of 1.25 as well. So keep those constant. Basically, just do what we just did, just with those two different numbers instead. All right, so let's go over this now. Pause the video if you haven't done this yet. This is a good exercise to try this for yourself. Right, so here we need our point slope form, which is y2 minus y1 equals m times x2 minus x1. We need our m, which is 1.25. We know our x1 comma y1 is going to be 12 comma 517.5. And then we know in this case, for example 4, our x2 comma y2 is going to be 23 comma y2. Plugging everything in, we have y2 minus 517.5 equals 1.25 times 23 minus 12. There. Once we have that, then we should get y2 minus 517.5 equals 1.25 times 11. This is going to be the same on the left-hand side, equals, and then this should be 13.75. Once I have that, I'm going to add 517.5 to both sides to get y2 equals $531.25 should be my answer there. Notice how I can round if I want to 531, but at least somewhere in my answer, I need to see this. So this number is what I'm looking for with all the decimal places. If you round your answer, that's fine. I don't care, but I'm not going to be looking for that when I grade this problem. Very important. All right, example 5 is pretty similar. Here, it's going to be the same exact thing, except this time our m and our x1, y1 will stay the same. So let me write those in real quick. But our x2 comma y2, whoops, x2, let me just rewrite that. That's a little messy. x2 comma y2, this time is going to be 3 comma y2. Right? So plugging this in, just make sure you plug in everything into the correct spot. So this should be y2 minus 517.5 equals 1.25 times 3 minus 12. And this is important because a lot of people want to instinctively put 12 minus 3. They always want to do bigger minus the smaller, but that may not always be the case. Once we get this, we get y2 minus 517.5 equals 1.25 times negative 9, then this should be negative 11.25. Then I'm going to add 517.5 to both sides to get y2 equals $506.25. And then here, if I wanted to, I could round to 506 or the nearest unit, but at least I kept this in my work, so that should be good for example number 5. All right, so question 5 will always be the same wording on your semester summative as it is here. Obviously, like the actual function and numbers may be a little bit different, but the wording will remain the same. On your AP exam, the wording may be a little bit different, but the criteria and what we're looking for will always be the same for this question, which is B part 3. Right? So let's break this question down because this one's pretty hard. Right? So first, let A of t represent the estimate of the amount of money that the student earns per month using the average rate of change found in part BI. What does that mean? So A of t is basically going to be the straight line because using the estimate for the amount of money the student earns per month using the average rates of change found in part BI. The average rates of change found in part BI is another word for that straight line, that slope that we used, that we found in part BI, right? We found that slope and we used that slope to predict a future point, right? We were like, well, what is t equals 20? What's that y coordinate? We used that straight line. So that is what the average rates of change found in part BI is that straight line that ran through those 2 points. And we're now calling that A of t just to keep it a little bit simpler than saying the longer name of it. And now the question actually asks us to explain why, for in general, the straight line, A of t, is going to be less than or lower or below m of t for all values where t is bigger than 12. Here we see 12 on the number line, and when t is bigger than 12, it's basically just on the right side of 12. Your explanation, we want to include a reference to the graph of L, and in this case it should be M, sorry, and its relationship to A of t. So this question is a lot to take in, so let's break it down. We talked about how A of t is that secant line that ran through those 2 points, 2 comma, or negative 2 comma 500 and 12 comma 517.5. That is the 2 points that formed that straight line. That was the same 2 points we found the slope of in part BI. A secant line, by definition, is a line that just runs through 2 points. So if you didn't know that, now you know. And then remember, model m of t, is that exponential function that we found in the very first part of this question, when we found the constants of a and b, and we wrote our 2 equations. That was working off of m of t. And we can see graphically, right? And you won't be able to do this necessarily with Desmos all the time, but we can see just with the general shape, right? If you have an exponential function and then you have it run through 2 points, when you go to the right of this point here, this exponential line will always be greater than the straight line. And why is that the case? Well, it's 2 reasons. One, the exponential function is concave up, right? Which means the rate of change is increasing for any concave up function, while the straight line is straight. The rate of change is constant. The slope is constant. The slope is not increasing or decreasing here because a linear line has the same slope. Because of this, the black line past 12, right, past that second intersection point, will always be above the red line for t is bigger than 12. Now, how do we word all that explanation, all that mumbo jumbo into an answer? And the answer is going to be like this. This is the perfect answer to this question. And so I would say this. First off, I would just restate what I am explaining. When they say explain why in general, blank, 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 start with that. So here, A of t is less than M of t for all t where 12 is bigger than t, or is less than t, right? That's what I'm explaining, because now I get to explain why. And then the first thing I want to say is you need to talk about the concavity of m, of not the straight line, right? Because the straight line doesn't have concavity, but the exponential, linear, or quadratic function. So because m of t is concave up, and the secant line from t equals -2 to t equals 12. So I am going to want the 2 points that form that secant line there. A lot of students just put the word secant line, but they don't put the 2 points that form it. That would be marked as wrong on an AP exam. So this is very specific. I need the concavity. I need the secant line, that word, those 2 words specifically, and then I need the 2 points that form it. And here, just talk about what is it doing, right? And the secant line from -2 to 12, right, because that's the 2 points that form it, is below m of t, and that's good enough for me, right? So here, the 3 things that I'm looking for is, and this came from the rubric from last year's AP exam, the graph of m is concave down, or you could say the equivalent of the rate of change is decreasing. I think this is a little bit easier to mention, right? M is, in this case, concave up, not concave down. So this was from last year's exam, and then I just changed it, but I forgot to change that. So it should be concave up. And then a reference to the use of a secant line from -2 to 12, or a use of a linear function with reference to t values -2 and 12 that provide placement of that line. I just would go with the first part here, right? Talk about a secant line and talk about how it is formed from -2 to 12. So if you don't have the correct endpoints, you don't have the word secant line, you don't talk about the concavity of m, and you don't have it flow together in a sentence, it will be marked as wrong on your semester summative exam. Right? That's why this question is so hard. Only 1% of students got this question right last year. So that is how you would answer question number 5 there. All right, and now, so for example number 6, find the reason or reasons why these answers would not earn credit for the question above. And this is a good exercise to figure out how AP grades and what I'm exactly looking for. So pause the video now if you haven't done this yet, because I am about to go over the answers. All right, so here are the same ones. I just added in my own words. And so here, the first one is wrong because the 2 points for the secant line, right? It should be -2 to +12, but here it says 6 to 12. That is wrong. So here, that is what makes this question wrong as well. Right here, it says the rate of change is increasing. That's okay. They say secant line. That's the second part, but the third part is wrong. For number 2, this one is too open for interpretation, right? When you say it is concave up, I don't know what it means. Is it the straight line? Is it the exponential function? Is it a random line that I drew on the paper 5 minutes ago? I don't know. So you need to be very specific, and instead of saying it, say m of t, right? It takes 2 seconds to write those letters out. So just write it. M of t is concave up, and then the line formed from -2 to 12 is below m of t. That is good, except here they don't use the word secant line. So they need to say secant line here. If you just say the line, it's not going to be specific enough and will be marked wrong. The third one here, because m of t is concave up, that's the first part, and m of t formed from those 2 points is graphically below the secant line. Technically, m of t is going to be above the secant line, not below the secant line. And so here, that's wrong. And also, m of t is not formed from those 2 points. The secant line is formed from those 2 points there. All right? So that's why the third one's wrong. The fourth one, the reason m of t is greater than a of t. okay, is because a of t is a linear model, while g of t is an exponential model, right? That's true. One, it doesn't provide placement of this line, so you need to mention the -2 and the 12 there. And then g of t, it doesn't talk about concavity. So that's something that you need to fix as well. And then the final one here, a of t is less than m of t where t is bigger than 12, because m of t's rate of change is increasing. Okay, yep, that looks good. And then the secant line formed from t is greater than 12 falls below m of t. That's not true. That's the interval that we're looking at to answer the question. But the secant line formed from -2 to 12 is really what you're looking for there. We care about what happens when t is bigger than 12, but that's not where the secant line is formed from. So really paying attention to small things like these. All these answers like on paper look like they could be correct, but there's small things that make them not. So just really make sure you understand the wording of what I'm looking for and that you don't mix up any words here. All right, so for question number 6, for which t value t equals 6 or t equals 29 months should we have more confidence in when using the model M? And so we want to give a reason for our answer in the context of the problem. And so for this one here, it's always going to give us two t values, and the correct answer will always be the t value that is between the interval of the points that we were kind of given or working with. So in this case, we were kind of working with t equals -2 and t equals 12. And so in between there, t equals 6 is in between there. Because t equals 6 is within the data used to create the model, we're going to have more confidence in that because we also don't know how the data will behave after t equals 12 months, right? So t equals 29 is way out there. And think about it, right? If we were plotting a point with 2 points there for maybe an exponential function, which is model M, which one are we going to have more confidence in? This point being correct or this point way out here being correct that is super, super high? And so it's always going to be the answer within. And then answers may vary for this one, but just talk about how 6 is between, the 2 points that you're going to be given on the semester summative. So try example 7, for which t value t equals 8 or 31 should we have more confidence in? Give a reason for your answer. Here, I would word my answer as t equals 8, so answer the question first, because you could say t equals 8 is within our points we were given. So we are more confident in a value inside the interval being accurate. That's like one answer that you can have. Obviously, it doesn't need to be that verbatim. As long as you just talk about, the reason being it's because it's within those 2 points and t equals 29 is not, that would be enough there. So that would be a good answer for example 7. All right, the alternate version that you could see is it was reported that the bank crashed and actually lost the students money after time t equals 20. So here, let's say we have t equals 20. Explain why the error in the model M, so this is model M, increases after t equals 20. So this is model M, but what the situation is saying is at time t equals 20, the bank actually crashes and loses money while model M still is expected to grow over time, right? An exponential function is not all of a sudden going to start decreasing. So what is the error even talking about? So the error in model M is how far off we were from our prediction, which is model M, was our prediction. And then this is, we could say, what actually happens. And so basically, how far off were we from our prediction to what actually happens? And over time, that is going to really increase, right? Mainly because Model M is going to keep going up, and the amount of money in our bank account in real time is actually going to be going down. So our prediction's basically going to get more and more wrong over time just because the two functions are going in opposite directions. So here on the rubric, it says to earn this point, the reasoning must include an implicit or explicit connection. So I just need to be able to tell somewhere in your answer that you know the function model, which is M. So basically, I need to see two things. I need to see you show me that M of t is increasing while the amount of moolah, of money, is decreasing, and showing that you know both of those things are happening kind of simultaneously after t equals 20. And so I would word my answer like this. The error increases after t equals 20 because m of t increases while the actual amount of money decreases. So the gap between them gets bigger. And that would be a perfect explanation that would get full marks for that question. And then the final question that you can see is the student plans to close the account when the amount of money in the account reaches $565. Explain how this info can be used to determine the domain limitations for the Model M. So this is really just going to be a question where you use Desmos. So here, $565 is the desired amount of money in this account. The account will be closed at time t equals c months, where basically that x value, you plug it in and it's going to hit 565. Therefore, the domain is limited to -10 to t2, in this situation, 42.632 months. This number is something that I would actually want to see on the semester summative for this type of question. So try example 8. The student plans to close the account after 40 months. Explain how this now is used to limit the range, so kind of the opposite direction. And here, I would use Desmos. So if you plug it in Desmos, we have our exponential regression here. You plug in x equals 40. We get this point here. So I would say, in terms of a correct answer, I would say 40 months is the desired length of the account. The account will be closed. So of the account, which closes when it hits 1981.07. Yeah, so $1,981.07. And then I would say the range is then 500 is less than or equal to m of t, which is less than or equal to 1981.07 there, right? So that should be my answer for example number 8. This FRQ is really important. You'll see this on the AP exam for sure and on the semester summative. If you have any questions, please come see me in office hours, and I will see you guys later. Thanks.